Now today we are going to perform practical, that is a determination of performance characteristic of DC series motor by direct load test. So there are two methods. One is the indirect method and second is the direct method. Indirect method is the field test is going to carried out in case of DC series motor, just similar to the symbol test in the DC shunt motor. But this is the practical setup for the direct load test. Here this part is the DC series motor. It is a DC series motor, and this part is the DC shunt generator, and it is mechanically coupled. So the series motor, it is only two terminal. It is connected one ammeter to measure the input current. To measure the voltage, we have selected DC voltmeter 0 to 300 and 0 to 10 ampere, because the motor which is we are going to test, it is up to the full load current is 6.5 ampere is there. So your A1 is connected, this is your A is connected to F1, F2 is connected to A1, and we have put one resistance only for starting purpose, and we will cut out that total resistance over there, isn't it? Or it may not be, you can replace this resistance by the direct link is there, only this starter resistance is sufficient. Now, DC shunt generator is that it is coupled, and so it become a load on the DC series motor. So whatever the output of DC shunt generator plus losses in the DC shunt generator is nothing but the input of DC shunt generator. So input of DC shunt generator is nothing but the output of motor. So we are going to load the generator, so it become a direct load test on DC series motor. Okay, so we will consider that we are going to observe this one is the motor side and second is the generator side. In the motor side, we will take the motor readings, whatever they say. For example, it is we have connected 220 volt and the current is say 2.5 ampere is there. So this is multiplication of this, nothing but the motor. Starting, we will take say 1500 RPM is there, and generator at no load condition, generator is 0, whereas it is at 230. Okay. Now we will load the motor at constant voltage. Suppose it is 1.5 ampere, or it is a 1 ampere is there. Say it is a 2.5 ampere is the motor input. Now after loading the motor input, we are going to find that there is a decrease in speed. You are going to calculate the load, that is a load on the shunt generator. You can increase the load by switching on the different type of different loads are there. So it is going to observe there is a load current of the DC shunt generator, voltage. So this is the output of DC shunt generator, isn't it? So in this way, what are the different parameters we are going to find? It is a VM, voltage applied to the motor. IM is the motor current. VL is the load voltage. What is the load voltage? Load voltage across the DC shunt generator load current, and RAG is the resistance of this generator. We are going to calculate this one. So this is the some practical setup and their observation. After performing the practical, we are going to fill up this table with the different observations at different speeds are there. Now how to calculate the efficiency and calculation? Okay, so what are the different calculations are there? Now we have already considered that whatever the output of generator, DC shunt generator, if you are able to calculate the losses in the DC shunt generator, definitely we are able to calculate the input of DC generator. And input of DC generator is nothing but the output of motor. So generator copper losses is I square RL. We are going to consider that the load current and generator armature current is very near to each other, which we have written. Load current is equal to armature current of the generator. So this is the copper losses at different load condition. How to calculate the constant loss in per machine? So constant losses per machine is nothing but the total motor input minus copper losses in the generator divided by 2. It is from the first reading. So we are able to calculate the total constant losses in one machine. If we are going to calculate, it is nothing but the WC. Now motor input Vm into Im already we have taken from the observation. Motor output, input of motor output is nothing but the output of generator. This is nothing but the output of generator plus copper losses plus constant loss. So output plus constant loss is nothing but the output of motor, and it is also called as a, this is generator input. This is nothing but the generator input. Now efficiency, motor output divided by motor input, we can calculate the efficiency. Similarly, we are able to calculate the shunt torque or shaft torque of the motor. It is 9.55 output upon speed. So at particular different speeds are there, we are going to calculate the torque. Now what are the different parameters we are going to find out? We have found efficiency, we have found shaft torque, we are going to observe the speed. So we can calculate speed versus armature current. So here is on y-axis is the speed and x-axis is the armature current. So we are able to draw the speed. So if we are going to find out that the speed is decreasing with respect to increase in load. Similarly, the torque also get increases with increase in the load, but there is the some different. It is the torque is directly proportional to here. Torque is armature torque is directly proportional to square of current. So you are looking such type of curves. Similarly, with a different load, what would be the efficiency? So we can calculate the efficiency of DC motor. So by this way, we are able to determine the performance characteristic of DC series motor by direct load test.